Hello, this is actually chapter 7. It's a big one. Exponential functions and log functions. You guys have heard of logs probably before, but you have no idea what they are. This is a big unit for in terms of content because it's very new stuff. Okay, let's just quickly talk about what you've been doing up till now. I mean, we've had several lessons. Covered several units, and you guys have been passing in your practice tests, and I've been marking them just for your feedback, for you to understand if you're getting the content. Those are not going to be used for marks. They're just for you to see if you understand. So those of you that have been getting help to do them and getting other people to do the answers for you, you're not helping yourself. The reality is, at the end of this year, we're still having a final exam, and that will be you writing and producing the content. Okay, so make sure that you have that attitude that you're trying to learn this, that you're trying to understand this. If you're going to continue math next year, this is really important. Think about that for a second. University right now is saying that 50% of kids fail calculus when they get to university. All right, if you don't have a good understanding of the grade 12 pre-cal course, you will not do well in the calculus course. Okay, so regardless of what your mark is, don't worry if your mark is, was an 85, it's probably going to be an 85 at the end of the year. That doesn't matter. What matters is that you're understanding the content. So please try to do this diligently. Work at it like you care about what you're learning, not about what your mark is. Don't worry about the mark. Okay? So let's talk about today's lesson, graphing exponential functions. Well, we don't know what this graph looks like, y equals 2 to the power x. So what we usually do is we start with a table of values. Okay, this is just for introduction. You are not going to need to do this eventually. But if we pick a couple of values, let's take -2, -1, 0, 1, and 2. If you put those into the function, so y equals 2 to the power -2. What's 2 to the power -2? Well, if you were in my class in grade 10, I said do 2 to the power 2, and then do the negative afterwards. So this would be 4 to the -1. Do you remember what -1 does? That's 1 over 4. Okay, so this is 1/4. Alright, now let's change that to y equals 2 to the -1. Well, that's just 1/2. What's 2 to the power 0? 1. What's 2 to the power 1? That's 2. And 2 to the power 2 is 4. Okay, so we can graph that. Let's put the y-intercept at 1, and then we're going to have at 1, 2, -1, -2. Okay, so this will be a quarter, this will be a half, this will be 2, and this one will be 4. So we can label that. That's 2, 4. This is 1, 2. Okay, now you can kind of see the shape of this graph. This is going to keep getting bigger and bigger here, so we're going to put an arrow. I mean, if you did 3, you could 3 to the power 2 would be 9, so it's going to go up very quickly here. Okay, what happens down here to the left? What happens here? Well, no matter how small we make this number, say like -100, this is never going to turn into a negative value. Okay, 2 to the power -100 is still going to be a positive value. Okay, it would be 2 to the power 100, which is a huge number, but then when we make it 1 over that number, it actually becomes very, very small. So this is going to be getting closer and closer to the x-axis, but never cross. So we actually have an asymptote here. Okay, so it's going to look something like that. Get closer and closer. Okay, state the x-intercept. X-intercept, none. It will never be 0. Okay, y-intercept, 1. Equation of the asymptote. Okay, remember equation is always an actual equation, so it's, y equals 0. What is the domain? Well, x could be -∞ to infinity. And the range, smallest value will be getting very close to 0 but not including it, up to infinity. Okay, so there's your exponential graph. Let's take a look at another one. Okay, again, we'll start with a table of values. Okay, so the first one will be y equals 1/2 to the power -2. Now the way I would do that is I would go 1/2 to the power +2, and I would put the negative out here. What's 1/2 to the power of 2? Well, 1/2 times 1/2 is 1/4. And what does this -1 do? That's the reciprocal, so you're going to get 4. Okay, now if we do the same thing with -1, you're going to get 2. 1/2 to the power 0 is 1. 1/2 to the power 1 is 1/2. 1/2 to the power 2 is 1/4. Okay, so this graph is going to look exactly flipped from the previous one. Okay. So this is 2 1/4. This is 1 1/2. And there will be an asymptote here. Now, when you normally graph an exponential graph like this, I'm not going to expect 5 points. Usually, when you graph, what do you need? I need a minimum of 2 points. Okay, those points should include the x-intercept and the y-intercept. If there is no x-intercept or y-intercept, then you need to find another point. Okay, so normally when I'm graphing this, I'm going to take the y-intercept, okay, and then I would pick one other point. Usually I'm going to pick the point where x is 1. I'll show you as we do more of these. Okay, x-intercept, none, y-intercept, 1, asymptote, y equals 0, domain -infinity to infinity, range 0 to infinity. Alright, so I told you that we're not going to use a table of values. So now I kind of want you to think about what do we know about an exponential graph. Alright, the y-intercept is a really easy point to figure out, right? Because y-intercept x is 0, so y is 4 to the power 0, y is 1. That's a point we can always draw on the graph. Okay, and now I told you when you graph you need another point. My advice is, let's figure out when x is 1. So you would go 4 to the power 1, y is 4. So at 1, you have the point 1, 4. And knowing that we have a horizontal asymptote, again, why do I have a horizontal asymptote? Because there's nothing I can put in here for x that would ever make it a negative number. Okay, so we'll have a graph that looks like that. And that's all you need to know for an exponential graph, just 2 points like that. Okay, it says state all the properties. Well, the asymptote's y equals 0. You know what the x-intercept is, there's none. The y-intercept is 1. Domain and range haven't changed. Okay, let's try this one. Again, y-intercept. Where is the y-intercept? It will be at 1. Okay, then let's check if x equals 1, then y is going to be 5/3 to the power 1, which is 5/3. So at 1, we'll have a point here that's 1, 5/3 with a horizontal asymptote. This graph is just going to be a little bit, I don't know if you want to call it shallower, it just doesn't rise quite as fast. Okay. Let's try this one. So y-intercept, if x is 0, you get 1. And then if we make x equal 1, y will be 1/3 to the power 1, which would just be 1/3. So this time, the point is down here. So you notice that now the exponential graph is, I don't know, we won't say it's going the other way. Whoops. So it looks something like that. Okay. So that's your basic exponential graphs. You can do a couple for homework. Okay, we'll just get started on this. There's not much to do. If you're doing this at home, you might as well get straight into the next lesson because there really isn't much in that homework.